Hello students, welcome back to our channel Abhyas IIT Prep. Today we are going to explain 23rd Jan evening shift paper. Let's get into the video. So see here question number 26. The internal energy of a monoatomic gas is 3 nRT. 1 mole of helium is kept in a cylinder having internal cross-sectional area. They have given 17 centimeter square and fitted with a light movable frictionless piston. The gas is heated slowly by applying 126 joule heat. If the temperature is raised by 4 degrees centigrade, then piston will move. So see this scenario. What is the scenario? We are having a gas which is having piston, container is having piston, this is our piston. Okay, in this we are having gas. If we are giving some amount of heat Q to this system, the piston will move some distance. You have to find that distance. So see here, we know that one internal energy can be written as delta U can be written as, they have given already 3 nRT. N is nothing but E. They have given 1 mole. I am not taking N. So R you can say 25 by 3 into T. What is the temperature? Temperature is 4 degrees. That is 4. So internal energy you are getting 100 joules. 100 joules. So what about heat? Delta Q already they have given 126 joules. If you find work done, so work done can be written as P into delta V. So see here, work done can be written as delta Q minus delta U, that is nothing but 126 minus 100, you will get 26 joules. This is our work done. What you have to find? You have to find the change in length. You have to find delta X. So see, work done I have written already, 26 joules equal to pressure into dV. Pressure, what is that one? 10 to the power 5 Pascal into volume. What is this volume? Volume is nothing but area into length. What they have given? They have given already area 17 centimeter square into X. Into X. So what is the answer? If you find this delta X, you will get 15.5 centimeters. This is your delta X. Okay, next question. 27. A body of mass of 14 kg initially at rest explodes into 3 fragments of masses given in some ratio 2:3. That is the ratio of masses. 2 pieces of equal masses fly off perpendicular to each other with the speed of 18 meter per second. Then the velocity of the heavier fragment. So when we are studying that law of conservation of momentum, this fragment, so bomb explosion is one of the best example. So see here, if a particle 1, take this x-axis and y-axis, if a particle 1 and 2 are perpendicular to each other, then it will go to another direction. Okay, third particle is going in xy plane with 45 degrees. So see here, from the law of conservation of linear momentum, so m1 v1 plus m2 v2 plus m3 v3. What do you have to find? You have to find the velocity of the heavier fragment, that is V3. M1, M2, M3. Okay, see here. M1, 2 into, what is the velocity? Minus, what is the M1? Downward, minus J cap plus 2 into minus x direction, minus x direction, 18 I cap plus M, that is nothing but 3 into V3 equal to 0. Okay. If you cancel this 3, you will get a 6 here and a 6 here. After solving this one, you will get a velocity V3 equal to 12 root 2. 12 root meter per second. What is the answer here? Option 2 is the right answer. Next question, 28. A block is sliding down an inclined plane of a slope theta at an instant t equal to 0. This is one case. And this block is given an upward momentum so that it start moving up an inclined surface with velocity u. The distance s traveled by the block, if block is before its velocity becomes 0, so final velocity is 0. Two cases are there. In first case, we are having a block is sliding down. Take this one, sliding down. We know this force mg sine theta, and we are one more force is there, that is a frictional force. So from this at equilibrium position, mg sine theta can be written as F. This is one case. What is the second case? If a same block is sliding up, same block is sliding up, acceleration is at upward direction. But in this case, we are having a mg. Okay, see here. In this case, we are having two forces, that is nothing but F and mg sine theta. Acceleration is acting upward. So for this case, what is the free body diagram? See here, mg sine theta plus F equal to ma. What do you have to find? You have to find the distance traveled by the block before it stopping. What is the velocity? Final velocity is 0. Substitute F here, you will get 2 mg sine theta equal to ma. So if you want to find acceleration, you will get a 2g sine theta. But we have to find the s. So s u, okay, see here, v square minus u square equal to 2as. S can be written as v square by 2a. V square by 2a. Because v is 0. So what is a? U square, that is 4g sine theta. That is 4g sine theta. So u square by 4g sine theta, option 1 is the right answer. Next, question number 29. The current passing through the conducting loop in the form of equilateral triangle of side 4 root 3 centimeters is 2a. They have given one triangle which is passing 2 ampere current. The magnetic field at its centroid is alpha times. They have given some value and you have to find the alpha. What do you have to find? Magnetic field at centroid. Magnetic field at centroid. Assume this is our triangle, okay, which is passing 2 ampere current, At centroid position, you have to find magnetic field. Magnetic field at centroid. So take this one. This is 60 degrees. This is also 60 degrees. But you have to find the R. What is R? Centroid. How to find out? Centroid R can be written as A by 2 root 3. A by 2 root 3. They have given A already 4 root 3 centimeters. So 4 root 3 by 2 root 3. From this one you will get R equal to 2 centimeters. So finally you have to find magnetic field. Magnetic field can be written as, okay, I am writing here, see, magnetic field at a centroid can be written as mu naught I by 4 pi into R sin theta 1 sin theta 2, that is 60 degrees plus sin 60 degrees. Mu naught by 4 pi, how much? 10 to the power minus 7. What is I? That is 2. What is R? That is also 2 centimeters. 10 to the power minus 2. What is sin 60? Root 3 by 2. We are having 2 times root 3 by 2. Cancel out. And one more is there, or root 3 into 10 to the power minus 5. 10 to the power minus 5. So what is the value of alpha? Root 3. Alpha value is root 3. Next, 30. A paratrooper jumps from an airplane and opens the parachute after 2 seconds of free fall and start a deceleration with 3 meter per second square at 10 meter height from the ground. While descending with the help of a parachute, the speed of the paratrooper is 5 meter per second, the initial height of the aeroplane. So we are having one aeroplane, one paratrooper is going down from that aeroplane. Okay, you have to find the initial height of the aeroplane. You have to find the height of the aeroplane. What they have given? So 2 seconds. V equal to, I am writing here, S equal to ut plus half at square. In this first case, u is 0 because he is at rest starting point. So S1 equal to half into acceleration due to gravity, that is g, 10 2 square, that is 4. You will get 20 meter. S1 is 20 meter. So what is the V? V can be written as u plus at. So u is 0. What is A? That is 10 into 2. You will get 20 meter per second. This is our first case. At 10 meter height from the ground, while descending with the help of speed, they have given speed, that is final speed. So from this one, case 2, v square minus u square equal to 2as. We are finding S2. So see, v square is 5 meter per second, that is 5 square, minus u square is 20 square equal to 2 into acceleration. They have given 3 and how to find? Yes. So S2 can be written as 62.5 meter. What is S3? They have given already S3. That is 10 meter. So S1 20 plus 10 30 plus 62.5. You will get a 92.5 height. So next question. Question number 31. Two short dipoles A comma B. Dipoles A comma B having charges plus minus 2 microcoulomb and 1 centimeter length, and B is having a 4 microcoulomb charge of length 1 centimeter are placed with their centers at 80 centimeters. Okay, this is 80, you are having 40 here and 40. Okay, as shown in figure, the electric field at point P, or to find the electric field at point P equidistant from the center of the dipoles. So how to find? See here, take this one, take this is P1, dipole P1, and in this direction also we are having E1. Take this P2 and we are having E2 in negative y-axis. Now see here, what is the value of E1? E1 can be written as minus 2k P1 by R cube, and E2 can be written as minus k P2 by R cube. Okay, so see, what is P1? P1 can be written as Q into distance, that is nothing but length. What is length here? 1 centimeter, that is 1 centimeter. So find Q1. 2 into 10 to the power minus 6 into 10 to the power minus 2, you will get 2 into 10 to the power minus 8. So similarly, P2 can be written as Q into L, that is nothing but 4 into 10 to the power minus 6 into 10 to the power minus 2, you will get 10 to the power minus 8. 4 into 10 to the power minus 8. So substitute in the equation E1, I am writing there. So E1 minus 2 minus 4 into 10 to the power minus 8. So k by, that is nothing but 9 into 10 to the power 9 by R, distance 40 into 10 to the power minus 2. This is our E1, and E2 can be written as minus 9 into 10 to the power 9 into 4 into 10 to the power minus 8 by 40 into 10 to the power minus 2. If you want to find E net, so E net can be written as E1 minus E2. If you solve this equation, if you substitute the values and if you subtract, you will get the answer 9 by 16. E net can be 9 by 16 and root 2 into 10 to the power 4. This is your E net value. Option 4 is the right answer. Next question, see. 32. Two charges 7 microcoulomb and minus 2 microcoulomb is placed at minus 9 and plus 9 centimeter respectively in external electric field. They have given electric field. You have to, okay. They have given A value. Consider the potential at infinity is 0. The electrostatic energy of the configuration. Electrostatic energy. So electrostatic energy can be written as U can be written as energy with respect to self and energy with interaction. Energy with interaction. What is self? Self is nothing but Q times of potential. Interaction is nothing but K Q1 Q2 by R. Q1 Q2 by R. X. This is position 9. At position 9 you are having minus 2 microcoulomb. At position minus 9 you are having 7 microcoulomb. But you have to find the potential. What is potential here? So potential can be written as dV equal to integral 0 to V minus integral 0 to R E dot dr. I am writing directly A by R square dot dr. If you solve this one, you will get A by R. What is the value of V? V can be written as A by R. What is the value of A? A they have given. So, what is the R? This is our R, 9. 9 is our R. So, see. I am writing here. U self, U can be written as Q1 V1 plus Q2 V2 plus K Q1 Q2 by R. What is the total distance between these two charges? If this is R, R is nothing but 9 plus 9. So 2R. You can write 2R. So see. What is Q1? Q1. 7 into 10 to the power minus 6 into A by R. I will substitute the values after some time. A by R plus, not plus, see here, minus 2 into 10 to the power minus 6 into A by R. Q. Q is nothing but 9 into 10 to the power 9 into 14 into 10 to the power minus 12 by 2 into 9 centimeters, that is 9 into 10 to the power minus 2. So, see here. If you see here, if you solve this entire thing, you will get the answer 49.3. This is your answer, 49.3 coulombs. 49.3 coulombs. Next, question number 33. They have given, I don't want to read this entire thing. So, see here, if a particle Q is there, it is traveling in this path A to B, and P is there, it is traveling A to A, C, B, that is their paths, P and Q. So, what you have to find? You have to find the relation between time taken by the Q and time taken by the P. So, if you observe here, the distance of a Q is greater than the distance of a P. In the question, they have given V is same. V is same. For two particles, velocity is same. So, TQ can be written as XQ by V, and TP can be written as XP by V. If you see here, these two are cancelled because these two are constant in this situation. So, similarly, TQ is greater than the TP. TQ is greater than TP. So, observe the options. So, TP is less than, so or you can write TP is less than TQ. This is our option. Option 2 is the right answer. Next question, see here, 34. A parallel plate capacitor with a plate separation I am writing here. This is our parallel plate capacitor, which is having separation 5 millimeters. 5 millimeters is charged by battery on introducing a mica sheet of 2 millimeter. Mica sheet is having a 2 millimeter thickness. Maintaining the connection of the plate with the terminals battery, it's found that it draws 25% of more charge from the battery. The dielectric constant of the mica. You have to find the dielectric constant of the mica. So, what is the condition here? So, final charge I am writing here, Q prime is 25%, that is 0.25% of initial charge, plus initial charge is there. So, you will get 1.25 Q naught. Okay. Next, for initial condition, C naught I am writing here, epsilon naught A by D. This is our initial condition without mica. So, epsilon naught A by 5 millimeters. What about after introducing mica? What is the capacitance? C prime can be written as epsilon naught A by D minus T plus T by K. What is D? D is nothing but the distance between the two plates, that is 5. So I am writing here C prime can be written as epsilon naught A by D minus T. 5 minus 2, you will get 3 plus the thickness is 2 by K. So see here, 3K plus 2 K epsilon naught A. This is our C prime. They have given condition in terms of charge. So Q prime can be written as C prime V and 1.25 times of mu naught, that is nothing but C naught V. Potentials are same. What is C prime? C prime can be written as K epsilon naught A by 3K plus 2 1.25 into C epsilon naught. C naught is nothing but epsilon naught A by 5. Cancel out. If you solve this equation, you will get a K equal to 2. You will get a K equal to 2. This is your answer. Option 2 is your answer. Next, 35. To compare EMF of two cells is using potentiometer, balancing lengths obtained 200 centimeters and 150 centimeters. The least count of scale is 1 centimeter. The percentage error in a ratio of EMFs. So we know that one EMF is directly proportional to length. So E1 can be written as lambda L1 and E2 can be written as lambda L2. So E1 by E2 can be written as E1 by E2 equal to L1 by L2. This is equal to R. So percentage error delta R by R into 100 is nothing but delta L1 by L1 plus delta L2 by L2 into 100 into 100. See here, 1 by 200 plus 1 by 150 into 100. If you see here, you will get answer 6 by 5, which is nearly equal to 1.16, 1.65. This is your answer. 1.65 is your answer. So next, question number 36. See here what they are asking. An air bubble of volume, they have given volume, raised from the bottom of this swimming pool of a 5 meter depth. Assume this is our swimming pool. One water bubble is there, which is having a height 5 meter. 5 meter depth is there. Okay. This is our water bubble. At bottom of the pool, water is at 17 degrees centigrade. What is the temperature here? 17 degree centigrade. The volume of a bubble when it reaches the surface when the water is at 27 degrees centigrade. So you have to find the volume of the bubble when it reaches the final position here where the temperature is 27 degree centigrade. What is the volume? We know that one, PV equal to nRT. So from this one, P1 V1 by T1 equal to P2 V2 by T2. Okay. P2 V2 by T2. So see, what is P1? Underwater, what is the pressure? Rho GH. What is the pressure? Rho GH. Pressure of atmosphere plus rho GH. What is the volume at bottom? They have given 2.9 by temperature. They have given already 17 degrees centigrade. You have to convert that into kelvins. How to convert? 17 plus 273, you will get 0 and 1 is there, 9. So you will get 290. This is our next one, P2. What is P2? PT is at final position. PT is atmospheric pressure only. So I am taking 10 to the power, that is P atm, atmospheric pressure. What is V2? You have to find V2. What is temperature? That is 300 Kelvin. 27 degrees means 300 Kelvin. So substitute the values. 10 to the power 5. Rho. What is the rho? Density 10 cube. G is a 10. Height, that is a 5 by 290. Next, this is not into, that is a plus. See, plus. Next, 10 to the power 5 into V2 by 300. You have to find the volume. V2. V2 can be written as a 4.5 kg per centimeter cube. It is nothing but 4.5 centimeter cube. That is option 4. Next question. 37, very easy question. Which of the following nuclei are isobar elements? What is the condition? Isobar element, mass number is same. Mass number is same. Observe, mass number not matching, not matching. This is our match. Option 4 is your answer. So how to remember isobars? Okay, see 38, question number 38, which is from digital electronics. This is belongs to logic gates. You know those things. Logic gate circuit, which of the following correct truth table? You have to find the truth table. First I have to find what is the output, then I will find truth table. N equal to N If you solve this one, you will get n plus m after z, n dot n plus m whole bar. From this one, n bar plus n plus m whole bar. If you solve this one, you will get a n bar. Okay, what is the output here? This is z is nothing but n bar. So see, n is 0, n bar 1. Okay, matching 0 0 not, n bar 0. This is also not matching. 0 to 1. Okay, and 0 to 0 not matching. 0 1 0 1 1 0 1 0. Option 4 is your answer. Next, question number 39. 1 mole of an ideal diatomic gas expands from the V2 to V isothermally at a temperature 27 degrees and does the work done W joules of work if the gas undergoes same magnitude of expansion adiabatically from 27 degrees centigrade doing the same work done. So what they are asking? So they are asking final temperature. What is the condition here? Work done in isothermal process and work done in adiabatic process is same. So what is the work done in isothermal process? Isothermal process. nRT ln V2 by V1. So n is nothing but 1 mole, that is 1 R. I am not taking here R. And the temperature 27 degrees, that is 300 Kelvin, 300 R. V2 by V1, you will get ln2. ln2 can be written as 300 R into 0.63. This is our isothermal work done. What is about work done in adiabatic process? Work done in adiabatic process. nR T1 minus T2 by gamma minus 1. This is our work done in adiabatic process. What is the condition here? What is the condition? T2 is your final temperature. You have to find T2. So see, what is the condition? Work done in isothermal process is equal to work done in adiabatic process. I am writing here 300 R 0.63 equal to nRT. N is 1. I am not writing n. R T1, that is 300. T final, that is T2. You have to find a T2 by gamma is nothing but 1.4 in case of diatomic gas minus 1. So RR gets cancelled. If you find T2, you will get a minus 56 degree centigrade. Minus 56 degree centigrade. This is our final temperature. Next question. See here. Question number 40. A prism of angle 75 degrees and a refractive index is √3. We are having one prism of 75 degrees centigrade, which is a refractive index n1 equal to √3, is coated with a thin film of a refractive index of 1.5. One coated with a film which is a refractive index n2. Take this one 1.5. Okay. At a back exit, to have total internal reflection at the back exit surface, the incident angle must be. So what is the incident angle? You have to find R1 value. If this is incident for total internal reflection, see, what is the condition? Total internal reflection. Sin R2 can be written as mu2 by mu1, that is nothing but n2 by n1, 1.5 by root 3, you can write 3 by 2 or 2 root 3, you will get a root 3 by 2. So R2 can be written as 60 degrees. We know that one A equal to R1 plus R2 equal to 75. From this one R1 can be 15 degree. R1 can be 15 degrees. Option 2 is your answer. Next question, 41. A circular loop of radius 7 cm is placed in a uniform magnetic field of 0.2 Tesla directed perpendicular to the plane of the loop. The loop is converted into again square in 0.5 seconds. The EMF induced in the loop. EMF induced in the loop. What do you have to find? You have to find EMF. EMF formula. What is the EMF formula? A rate of change of magnetic flux. What is flux? Flux can be written as BA. Here you are having two areas. You have to take phi equal to B into final area minus initial area. Okay. First you have to find A1 and A2. They have given circular loop. First we are having a circular loop, then in 0.5 second that is converted into a square loop. Then you have to find the magnetic field of this square loop. Okay, this is a radius. They have given 7 centimeters. What is the circumference? 2 pi r, that is nothing but 14 pi. This is its length. What about side of this square? So side of this square is nothing but length by 4, that is nothing but 14 pi by 4, 7 pi by 2. This is our side A. So area of a square, that is A2. A2 can be written as 7 by pi by 2 into 10 to the power minus 2 whole square. What is our A1? That is nothing but pi r square. Pi, what is r? 7 into 10 to the power minus 2 whole square. Okay, see here, phi equal to B, magnetic field 0.2. So I am writing directly E equal to d phi by dt. What is the area? You have to substitute areas. What is A2? 49 pi square by 4 minus r 49 pi square into 10 to the power minus 4 by 0.5 second. If you solve this one, you will get E equal to 1.32 millivolts. E equal to 1.32 millivolts. Your answer is 4. So next one, see here, question number 42. A long solenoid of 10 centimeter length, radius 2 centimeter, having 50 turns per unit length, carries a current I. They have given I and omega. A circulating conductor loop B of radius 1 centimeter coaxially slided through the solenoid at a speed 1 centimeter per second. The RMS current through the coil B when it is inserted 10 centimeter inside the solenoid is. So we are having a solenoid A of length 100 centimeters. This is our solenoid A, and one more solenoid is there. that is a circular conducting loop. So we are having a circular conducting loop. One more loop is there, that is a B of radius of 1 centimeters, and this is 2 centimeters. So when it is inserted 10 centimeters, what is the current, RMS current through the loop in B? RMS current, IRMS can be written as I by root 2. What is I here? I induced. So I is nothing but mu naught n I naught pi r square by omega into omega by r. What is r? They have given already 10. So IRMS equal to mu naught, that is nothing but 4 pi into 10 to the power minus 7, n is nothing but 500 into I naught, that is nothing but 10 into pi. What is r? 1 into 10 to the power minus 4 into omega, that is 100 by root 2 r, that is nothing but 10. If you solve this one, you will get 197 by root 2. 197 by root 2 microamperes. 197 is your answer. So next, question number 43. The ratio of speeds of electromagnetic wave in a vacuum and medium having dielectric constant K3. So dielectric constant K is nothing but epsilon r. Permeability is a mu equal to 2 mu naught, that is nothing but mu r equal to 2. What you have to find? You have to find a ratio of a speed of electromagnetic wave. So see, mu can be written as a C by V. Okay. Next, this is nothing but mu r epsilon r, that is nothing but 3 into 2 by 1. This is nothing but root 6 by 1. Option 4 is your answer. Next, question number 44. When polarized light falls at a particular angle on a glass plate placed in the air, it is observed that the reflected beam is linearly polarized. A reflected beam is linearly polarized. That is the condition for Brewster's law. The angle of a refracted beam with respect to the normal. Angle of a refracted beam. So from Brewster's law, we know this condition. Tan theta can be written as mu 2 by mu 1. So if you see here, this is our mu 1 and this is our mu 2. Mu 1 is nothing but refractive index, that is nothing but equal to 1, that is air, and a glass 1.52. Mu 2 1.52 by 1. So tan inverse 1.52, that is nothing but see here, incident angle is nothing but, this is theta can be written as I, that is nothing but 57.7 degrees. What you have to find? You have to find r. R is nothing but 90 minus 57.7 degrees. If you observe here, you will get the answer 32.3 degrees. Option 2 is your answer. Next, question number 45. A small metallic sphere of diameter 2 mm, density they have given, and dropped in a viscosity liquid of viscosity 10 poise, and density they have given, the terminal velocity attained by the sphere. Terminal velocity, very important formula, 2r square g by 9 eta rho of solid minus rho of liquid. What is 2 into R? They have given diameter. I am writing R 0.1 whole square into G, that is nothing but 10. 9 into eta, that is a 10 poise. Rho solid. That is a density 10.5 minus 1.5. If you solve this one, you will get a 2 centimeter per second. Velocity of the terminal velocity of the ball can be written as 2 centimeter per second. Option 1 is your answer. Next question, see here, section B. This is a numerical section. The average energy released per fission. Average energy released per fission, that is a 190 mega electron volts. When all atoms of a 47 degree pure uranium-235 undergoes a fission process, the energy released in alpha times 10 to the power 23, then the value of the alpha. How to find energy released? Energy released can be written as, energy released E can be written as number of moles into Avogadro number Na into energy released per fission. How to find number of moles? So number of moles equal to 47 by 235. You will get 1 by 5 times of moles. What is Avogadro number? 1 by 5 into Avogadro number 6 into 10 to the power 23. Energy per released per fission, that is 190 mega electron volts. 190 mega electron volts. This is 3 plus 4, 8. 38. You will get 228 mega electron volts. 228 is your right answer. Next question. The size of images of objects is formed by the thin lens are equal when the object is placed at two different positions, 8 cm and 24 cm from the lenses, and then the focal length of the lenses. So what is the condition here? So m1 equal to minus m2. Magnification is equal to minus m2. So f by f u1, f by f u2. So see here, 1 by f minus 8 equal to 1 by what is minus f minus 24. After this one we will write f equal to 32 to f equal to 32. F can be written as 18. F can be written as 18 centimeters. Next question, question number 48. See here, question number 48. This is our solution. A ball of radius r and density rho is dropped through a viscous liquid of density sigma and viscosity eta attains its terminal velocity t is given t. They have given a rho to the power a, r to the power b, and eta to the power c, and sigma to the power d, where a is the constant and bc are the integers. Then the value of a plus c by a plus d, b plus c by a plus d. So see here, this is our rho formula, ml t to the power minus 2, and r to the power b, so l to the power b, from again viscosity ml l to the power minus 2, t to the power minus 1, to the power C. And what is this one? Sigma to the power D. ml L to the power minus 3 whole to the power D. So if we add this M powers and L powers and T powers, you will get this one. In the left side, if we compare this one, C1 can be written as minus 1 and A plus C plus D, that is 0 minus 3A minus 3A minus C minus 3D plus B, because in this left side M equal to 0, L equal to 0 and T is 1, T to the power 1. So B equal to 2 and A plus D equal to 1, B plus C equal to 1. So C plus D by is nothing but 1. Next, question number 49. Suppose there is a uniform circular discus mass m kg and a radius r meters as shown in figure. The shaded regions are cut out from the disc. The amount of moment of inertia remained about the axis of rotation, that is A, is given by x by 256. So what is the condition here? This is our r by 4. Remaining we are having 3 by 4 times of r. So for this one we have cut two spheres same size. What you have to find? You have to find the inertia, moment of inertia. So from this one, see, moment of inertia of the system for a total mass mr square by 2, but a small mass, as a parallel axis theorem, as per parallel axis theorem, for mr square by 2, mr square by 2 into, so this is nothing but mr square by 2, but here r is nothing but r by 4, that's why r square can be written as r square by 16, r square by 16. Okay, remaining part is there, perpendicular distance mr square. This is as per parallel axis theorem, ICM plus ID can be written as mr square by 2 plus mr square. What is r? Remaining r 3 by 4. So r is 3 by 4, m into r is 3 by 4, 3 by 4 into r square, m into 9, r square by 16. This is your answer. We are having 2, that's why I am multiplied with 2. Next, if you solve this one, you are remaining with this equation. mr square by 2, 19 mr square by 256. So we know that one m equal to capital M by r. We have discussed here, that is capital M by 16. Capital M by 16. Okay. Substitute this small m. So substitute this small m. You will get this equation. After solving this 109 mr square by 256, your x value is nothing but 109. So next question, see here, question number 50. Velocity of sound in air is doubled when the temperature is raised from the 0 to alpha degrees, then the value of alpha. Velocity of sound in air can be written as under root gamma RT by capital M. By capital M. So V is directly proportional to root T. What is the condition here? When the sound in air is doubled, so velocity V can be written as 2V, that is nothing but root T1 by T2. Then what is the temperature? What is the alpha value? So VV gets cancelled. If you square it, what will happen? If you square it, what will happen? What is the temperature? T1, that is 0 degrees. 0 degrees means you are not able to substitute 0 degrees. You have to substitute 273 Kelvin. 273 Kelvin. T2 can be written as 4 times of the 273 Kelvin. 273 Kelvin. So they are asking degree centigrade. So you have to write 3 times of 273 degree centigrade. So this is your answer. 3 times of 273 degree centigrade. So thanks for watching. This is our end of the class. If you are having any doubts, please comment below. Thanks for watching.